Hello everyone, welcome to the second section in the Numpy tutorial. So in this section, we are going to practice and discuss what are the various methods or there available, built-in methods available that we can use to create arrays. And what are the different kind of array-oriented operations. The methods that can support the array-related operations are available in Numpy. Okay, so we'll discuss that. And as usual, have a Jupyter notebook file. You can just create a Jupyter notebook file for the second practice. Okay, so first we are going to see how we can use the methods, built-in methods like zeros, ones, all those methods to create an array from the scratch. Okay, so this zeros, ones, these arrays are there in any kind of matrix related languages. Like for example, MATLAB has the same MATLAB or okay, all those number related array related languages has these built-in methods. We'll see one by one. You can just do the practice with me. We're just going to practice different methods. Okay, so I suggest you to create submit it as a separate file. Okay, so first thing, Numpy has the function called zeros. Okay, tab, it will create, you can just pull the zeros function. So you can just pass the parameter like how many elements that you want to create. Okay, with that, it can be one-dimensional array, two-dimensional array, or any. If you want to create something two-dimensional array, you can do the same thing. Maybe the zeros. Pass row and column value, it will create two-dimensional array. And Numpy has a method called ones. Okay, tab ones. Okay, so this one, instead of zeros, it will create an array with ones in it. Should be a method, and inside the method I'm passing these tuple values. So you can see it will create an array with ones. Similarly, Numpy has a function method called empty. That empty method will create an array without initializing its values to any particular value. Here we are initializing it to 0 and 1. But you can simply, if you want to create something random, then you can simply create Numpy empty. You can simply specify the size. For example, 2 cross 3. So you can see it will just randomly pick some values, where this value actually, most of the cases, it will return the garbage value. So RAM has some garbage values. It will just, after using some object values, it will just throw it away. It will just pick those garbage value and just show it here. Okay, this is empty. Mostly we will use random number generation for this kind of empty creation. Empty we will not use that often, but just know that there is a method called empty that will just create some random array with a given size with random values that it will pick from the garbage values. Okay, similarly, you can just use the range function. You should be familiar with the range function in Python. The similar function in Numpy is called arrange. So instead of range in Python, arrange in Numpy. Okay, so this just will pick the values from the given range. We'll just pick the values from the given range. Okay, so if you give 15, then from 0. If you give 15, it will just leave the value in number. In Python, the range function will leave this value, and it will just display the values before that. The same thing will happen with the arrange function in Numpy. Okay, so what else we can do? Let's do some more operations from things that we learned here. Okay, you can just do arithmetic operation. Here you can see this will create ones with the size 3, 5, and this 5 plus will just create arithmetic operation. So with all ones, 5 will be added with each and every element. So this is why it is so efficient. This creates element-wise operation. Element-wise, all the operations will be done in element-wise. Okay. So that is the advantage. That's why it is fast and efficient in NumPy. If you need to do it in Python, you have to do the looping, for looping, or it's kind of a little bit complicated. But if you use NumPy, it is you can accomplish it with Q coding. Okay, so there is one more method called I. So I means identity matrix. Okay, identity matrix. Let me show you what it will do. This I method will create identity matrix. The identity matrix value should be always square. Okay. So you can see 4 means 4 cross 4, row 4 value and column 4 value. So it will just keep the diagonal value with 1. Okay, that is I matrix. The same thing can be done by another method called identity. So I'm going to create another variable where tab I'm going to see, you can see there is another method called identity method. So that also I can use here. I'm going to create 8 cross 8 mat2. So you can see diagonally, only in the diagonal values, the 1 will be set. In other positions, the value will be 0. So this is how the I matrix identity, both will do the same thing. Okay, both methods will do the same operation. So next thing we are going to see from function. So NumPy has a set of functions called starts with from iterator from. Okay, the from function we can generate array by writing some condition. Okay, so I can simply give a condition and based on the condition the array will be created. Okay, so let's do some of such kind of operation using from function. You can see NumPy dot from function. If you type tab and type from, then you can pick a lot of from functions where we are going to do from function. Here you can see it is an anonymous function. The condition is given here using lambda function. You can look at the condition where I equal to j, 3 cross 3 matrix, I equal to j. So it's going to be the Boolean. And it is going to be the Boolean value wherever I and j value index position is 0, 0, 0, true. 1, 1, this is 1, 1 position, which is true. And this is 2, 2 position, which is true. And this one is 1, 0 position. That is row value is 0 and column value is 1. Okay, so 0, 1 position, which is false. Okay, so where the index value is equal, there the Boolean value is 1. So let's create one more array by using the from function. This time I'm going to do the 3D array with 3 cross 3 matrix. Okay, let's see how it looks. I forgot to close function. You can see I have created 3 cross 3. This is already 2D array, and then I have created an array of this array. So that is 3D array. Okay, 3D array. And we'll do something with 4D array now. So here you can see it is 4D array, okay, with I, J, K, M, 4 values. You can see this is how the 4D array looks like. So we actually in 3D world, like 3-dimensional world, we can just assume and we can just visualize 3 dimensions only. So it is hard to explain how 4D array looks like. But yeah, so for us to visualize it is hard, but for NumPy, for data except the data visualization libraries, but for other package, numerical related array related packages, handling that multi-dimensional array is not that tougher. Whether it is 2D or 10D, it's going to be same. But the thing is like we will not be able to understand more than 3 dimensions because the world we live in is 3D world. Okay, so 3 dimension only we can understand and visualize. Okay, so I'm just moving on. We're not going to work on the 4D array. Okay, so maybe until 3D array, we can manipulate the data. But you know what? There is a library called TensorFlow. Okay, TensorFlow library has specially designed to handle multi-dimensional data. It doesn't have any restrictions like 2D, 3D, 4D, or it can work with any kind of dimensional data. Okay, so that is called TensorFlow. Okay, so that is for advanced data analytics. But as of now, in terms of dimensional array, where you will apply. If you take the 2D array, it is like any kind of relational database that has rows and column will be applicable. Okay, so the 2D array can be applicable in any kind of relational database. Or if you take the image has rows and columns of pixels, right? Each and every row or column of pixel can be taken as 2-dimensional array. Okay, so for 3D array, you can consider video processing. In other than the length and width, the pixel values, it has a time frame of each frame. Each time they have the image frame, right? So that can be taken as the 3D thing. Okay, that can be the example for video processing. Yeah, so 4D array, multiple, like when you consider multiple features together, then you can consider each feature as a dimension. Okay, it's hard to explain this current stage, but when we move on with the signal processing related stuff, then you can easily understand. So as of now, this is how we can use. This is how we can create and manipulate the data. Okay, next we are going to see from iter function. So like from function, from iter function also will be helpful to create array, but it is iterable object. It just creates an array with iterable objects. So if we want to convert it into array, that the particular iterable related functionality, if you want to convert it into an array, we can use from iter function. Okay, so maybe I'll show you an example for that from iter. Okay, from iterable, I'm just creating a variable iterable, and then here is this condition x squared for x value that ranges from 0 to 4. Okay, so let's see what is there in the iterable variable. And then now we are going to tab from iter function, where I'm going to pass the variables. You can simply press the tab that will show you what are the variables that we have. Iterable is the variable where we want to handle it like a floating point. So you can see that creates the iterable objects. Say x, 1 square, 2 square, 4, 3 square, 9, like that. It will create anything. So this is how we can use the from iter function. Same thing, there is another function, similar function called from string function that will create array from string. Already we have done this, how to create an array from string, but there is a function for that will do this job called from string function. Okay, so I'll show you how it can be done. So from string function, we can pass the string and we want to convert it into float. And here the separator is this colon. Okay, you can simply specify the delimiters. If you don't have any separators here, you can simply give the space. But here the separator is colon. Okay, so you can see how it just convert that string into floating point, and also it removes that delimiter, the colon thing here. Okay, so we'll do one more to make you more clear from this. Here I have another string. Here I have the separator as a comma, and let's see how it does. Okay, you can see we'll just remove the string and convert it into integer. Okay, by default it will add comma. So that is about from functions. We have seen from iterator, from function, and then from string. So next we're going to see from array. Okay, from array, how It is used to create an array with an existing array grouping based on the index value. Okay. So how to create a new array from the existing array? So for that, we're going to use a special function called from arrays, which is there in the package records, which is there in the package core, which is a part of the package of Numpy. So I'll show you how it works. I'm just creating bunch of arrays. So the from arrays will help you to create array from another set of array. So here I'm good. So you can see x1, x2, x3, x4, all of them are array. Now I'm going to create a new array with all these arrays as an element. So for this, I'm using core.records.from arrays. Here you can see how it creates a new array. You can see it creates a new array, okay, with the existing values. So if, for example, let's try to access few values. One index, one row, and one column value, that will fetch this GD. Okay, 0, 1, 1 of 1. So it will just fetch this DD. Okay, so far we have seen from functions like from function, from iter, from array, from string. Next, we are going to see linspace and logspace functions. What is linspace? So linspace is a function that is part of Numpy package. It always returns the number with a given interval. Okay, similar to arrange function, Numpy arrange function, but the thing is like here, instead of specifying the range of values, it works on the count. You can give the starting value and ending value. You can specify how many values you want to pick with the same interval. Okay, so how many that will be given as a parameter, third parameter. So if I run this, you can see between 2 and 3, we want to pick 5 values, including 2 and 3. So 1, 2, 3, 4, 5. You can pick 5 values. Next, we are going to pick 10 values. Okay, 2.0, 3.0 with 10 values. So excluding this 5, this endpoint, when you make it false, so what it will do, it will just starting position, ending position, number of iteration, endpoint is false. You can see excluding 3.0, it will just give 5 values. Okay, so exclude endpoint false will exclude the last point. One more example where we are specifying the steps. So repeating step, okay, so the step size will be visible. When you say step size equal to true, that step 2, and it will give you the step size here. You can see the step size starts from 2 to 3. It has 9 values. So what is the step size with the iteration? So you can see 0.125. That step value will get printed. So that is about linspace function. Next, we are going to see log space. So log space, using that we can generate an array of logarithmic value. It can be of any base. For example, let's create a log space of 10. So for this, we will use log space function. Okay, so I'm just going to create log space. np.log space, starting value 3, 2, ending value 3, number of iteration 4, and the base is 10. So run it, you can see with logarithmic of 2 and logarithmic of 3 with the base 10. Logarithmic of 2 with the base 10 is 100. Logarithmic of 3 with the base 10 is 1000. So between this value, it has 4. It just picks 4 values. So we'll do same thing with base 2. And see np.log space 2 to 3 number of spaces, let's say 10, and base is 2. So you can see 2 power 2, 4, 2 power 3, 8. Between these two values, it just picks 10 values in between these. Similar log of 5. Imagine if you have to write the conditional statements and loop to do this, how much code it will take. So you can see this can be done easily with few lines of code. With a single line of code, you can do this job. Okay. So with the packages, with the methods available in Numpy package. So 2 power 5, 5 power 2, 25, 5 power 3, 125 with the 4 values interval. Okay, so those are the methods available. So we'll do a short review on what are the methods available. Array, simply convert input into data. Okay, and D type will specify that I will pick the data type of the array, and as type will, as array will convert in the data into array, but the thing is like it will change the original array. The array will not change the original, it will create a copy, but this one will change the original array. And then ones will create number of ones. Ones like takes another array and produces. We'll do the same thing with copy. Similarly, zeros will create zeros of arrays. Zeros like will create another array, will do the copy. Empty function will just pick the values and put some random value, garbage value. Empty like will do it new. Similarly, full like just do some more explore some more other things, but the methods, whatever I have explained here, is kind of popular in terms of real world applications. Identity are also sometimes you may need to familiar with those functions. Okay, next we're going to see upcasting. What is upcasting? So when you have one data type here in this array, you have 2 integers and 1 floating point. So because of this one floating point, when you process it with the array function, it will create the memory size of float for all the available functions. That means if one data is float, it will convert all the integer data to floating point data so that it can take more space. Okay, so next we are going to see about matrix. So array means we know that it can handle multiple dimensions of array. Matrix is nothing but 2-dimensional array. Okay, so it has strictly 2 dimensions. We can convert the array to matrix, but matrix to array is not possible. Okay, we can convert the 2-dimensional array to matrix, but matrix cannot be converted to array. Okay, so to check it, so is subclass is the Boolean operator. So if you pass this, it will tell you whether the matrix is part of array. So it says it is true. Okay, so let's do some matrix related operations now. Okay. So here I'm going to create a matrix by using matrix function. Okay, matrix function. Inside that I'm creating it using list and passing it to array, and then I'm passing that to mat function because mat function is a part of NP package. So I'm just going to see the type of M1, and also I'm going to print M1. So you can see now it says matrix. So far it says array, but now it says matrix. Okay, now let's see how to create matrix from the list all by itself. So you don't need to convert it into array like this. You can simply pass the list of values to matrix function to create matrix. Okay, so it creates matrix. Similarly, you can do it from string as well. So I'm going to pass some string values to mat function that will create the matrix. Okay, you can see you can just work with the 2-dimensional array, which is all about matrix. So we have sleep so far, methods, from functions, linked log, space function, matrix. So next we're going to see how to do arithmetic operation with Numpy. So let's create as empty. Let's create an array with some values. Okay, so I have just created a 2D array, some values. And now I'm going to do some arithmetic operations on that. Okay, array. We'll just give you the element-wise multiplication, 1 cross 1, 2 cross 2, 4, 3 cross 3, 9, like that element-wise multiplication can be possible. So array minus array, 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0. Okay, so element-wise subtraction can be done. Now let's see the division operation. Okay, you can see 1 divided by all the given values. And see exponential operation for each element. Okay, so like that, any kind of arithmetic operation can be easily done using Numpy package. Let's do some multi-dimensional array related operations now. Okay, so let's create a data with a random integer value. We'll see how to create random number generation in Numpy. But right now, I'm just creating a random array with some random value. Okay, so I'm just, so we have already seen this. Maybe we'll do some other reshaping with some other data. I'm just going to create 2 matrices. Sorry, not matrices, 3 cross 3 array. And how to display the answers for this perfectly. Okay, we have created 2 arrays, input. So here we're going to see it in detail later on. I'm just using the package called RA package, which is part of random number generation dictionary. Okay, so I'm just using that to create some arrays. Okay, to create some arrays. So you can see the matrix, 2-dimensional matrix with the given value, with the reshape function, all those 3 things we will see it in detail. I'm going to do the same similar kind of operations, but little bit more advanced. Here you can see math 1 divided by 0, 3 math, and 2 into math. So you can see how it can retrieve the values. So let's do some more advanced operations with power or exponential here. You can see exponential math 1, double start 3, math 1 with power. You can see exponential, square root function, exponential function. So both are power. So maybe I will just do square root. SQ or T. Okay, I'm just doing the exponential function. Okay. Next, let's see some Boolean result. Okay, some Boolean result, because next we are going to see how to work with the Booleans. One of the sections. So comparison between arrays can be done. Always will give Boolean result. Example here, I have created one array and name it as array 2. And we're going to see whether array 2 is greater than array. So when we do this, it will just do the element-wise comparison. You can see the array values here. This is array value. Maybe I'll show you. So this one is array value. And we are doing comparison, whether array 1 is greater than array 2. So first one, array 2 is bigger. So false. So like that, it will do the element-wise comparison. Okay. So that is about this section. So we'll do a review. So what we have seen in the section 2, we have looked at different built-in methods to create arrays, starting from zeros, ones, empty, identity, and from function, from iter function, from string functions, from array function, lint space, log space, and what is upcasting, how it will be done automatically, what is matrix, and matrix related operations, matrix related functions, and arithmetic operations in array. Okay, how it can be done in element wise. We have seen two different examples to explore it. Okay, and then comparison operations between the array. Okay, so that will give you the Boolean values like this. So in the next section, the section 3, we are going to speak about shaping, indexing, and slicing. See you in the next video tutorial. Thank you.